This conference will now be recorded.
In last lecture, we have completed a scanf function. So what is actually a scanf function do? What your scanf function will do? Please reply. What your scanf function will do? Instead of reading input from the keyboard, it is going to read a input from the string. String array, any format. Reply fast. Okay, after that we started with the standard output buffer. What actually is your standard, how your standard output buffer works? How your standard output buffer works? How it is work? How it works standard output buffer? When I am going to print the output, it is going to print on the terminal directly, or whether it is going to standard output buffer. Where it will go? When you are going to print something, it will go to the standard output buffer. From standard output buffer, when it will come to the screen? When it will come to the screen? From standard output buffer, when it will come to the screen or monitor? When one of the 5 condition is satisfied, at that time it will come to the screen. Please tell me that those 5 condition. Please tell me those 5 condition. What are those 5 condition? Normal program termination. Then next, in printf if you are using /n or your buffer contains /n, at that time whatever is in the buffer, it is going to print on the terminal. Third thing, read means when you are going to read a input from the when you are going to read a input from the keyboard, at that time whatever they are in a buffer, output buffer, it is going to print on the screen. Fourth one, flush, by using flush function. Okay, means we are doing forcefully flush. Manually you are flushing the output on the screen. And last is what? When buffer is full. When buffer is full. Correct. Now after that we saw a standard std err, standard error output. Sorry, standard error buffer. std err buffer. So what is the difference between std err and std out buffer? What is the difference between std err buffer and std out buffer? For flushing the output on the screen, std out buffer will wait for the condition. If one of those 5 conditions will be true, at that time it will throw. But std err will not wait. It will directly throw the output. Sorry, it will throw the whatever content in your buffer. In std buffer, it will directly throw. It will not keep inside it. It will directly throw. Same thing we can do with std out buffer. We can change the buffer also. We can remove std out buffer also. Okay, like std out buffer, how std out it will not keep inside anything. Similar, same thing we can do with the std out buffer also. If we want to don't set our output to the std out buffer, we can't send. We can do like that also. If you want to remove out std out buffer, if you want to remove any buffer, std out buffer, you can remove that buffer output. You can remove that buffer of output. There is a default option we have. Okay, there are some function we have. some standard function you have. Using that function we can remove the output buffer. Means what will happen, instead of going that buffer, instead of going output to the buffer, it will directly go to the terminal. So what are those functions? So for removing buffer or changing the size of a buffer, we can change the size of buffer also. For removing the buffer, for changing the size of buffer, we have setbuf function. Using setbuf function, we can remove. Okay, let us do man on setbuf. setbuf. Let us do man on setbuf. See here, you will see this function. Using this function, we can remove the buffer. Yesterday out buffer we can remove, or we can change the size of buffer. We can change the size. Instead of, I can say we can change the buffer location. Instead of using the system buffer, I can create my own buffer. Okay, these are the function we can use to remove also or to change also. Okay, so if you see the description, here it is written that 3 types of buffering available are. Using this function we can do 3 types of buffering. The first thing is that unbuffered. Unbuffered means what? Unbuffered means, sorry, I started recording. Okay, I started. Unbuffered means what? Unbuffered means we can remove the buffer. Unbuffered means what? We can remove the buffer. Instead of going your output to the yesterday out, instead of going your output to the yesterday out, it will directly go to the terminal. That is meant by unbuffered. Second thing is the block buffer. Using this function you can do block buffer. It means that instead of going to the system output buffer, I will create my own buffer of a less size. Means I can change. We can use different memory other than system memory. That is meant by block buffer. And third is the line buffer. Means it is going to print the output line by line. Whenever your output buffer got /n, at that time it will print the output to the terminal. Okay, it is normal. It is similar to our normal output buffer. Okay, let us see how to do it. Suppose I am going to write a code vi buffer.c. Suppose I am taking one example like that, while printf. Now tell me, for this example, when your buffer will throw the output. For this example, when your buffer will throw the output. When which conditions, after which conditions satisfied, your buffer will throw the output. See, summarize all the 5 conditions. First condition is what? Normal program termination. Your program will not terminate. This loop will execute infinite times. Second was /n. /n is also not there. Third thing is what? Read. I am not reading anything. Fourth thing is what? flush. I am not using flush. Only last thing is there. Buffer full. When your buffer become full, at that time it will print the output on the terminal. Okay, if I am going to execute it, it will not execute. Sorry, it will execute. If you observe this here, it will not print anything until your buffer become full. When your buffer become full, at that time it is going to print. When your buffer become full, at that it is going to print. So what I am doing, suppose what I am doing, I am going to remove the buffer. Means what I am doing, I can remove the buffer. Instead of going our output to the standard output buffer, I am sending my output to the terminal directly. So I can write like this. So what can I do for that? If I want to remove the buffer, I can write the function like this: setbuf. If I want to remove the buffer, I can write like this: setbuf std out, means which buffer I want to remove. My buffer is std out buffer. In std out buffer it is going, so I need to write std out there. And if I want to remove there, I need to write null. I am going to write null. Okay, actually instead of null we are writing their array, base address of array. Instead of null I am passing the base address of array. Because of that, what will happen, instead of going your output to the std out buffer, your output will go to that array. Your output will go to that array only. Instead of going to the std out buffer, your output is going to that array. But here I am passing to the null. But here I am passing a null there. It means that I don't want any buffer. I want to print my directly output to the terminal. So tell me what will happen here now. When here it is going to print, now I am going to remove the buffer. Now when it is going to print 1, what do you think? Now buffer is not there. Now how it is going to print? We know it is going to print 1, but how it is going to print? What do you think how it is going to print? It is going to print 1. Wait for 1 second. Again print 1. Again wait for 1 second. Again print 1. For every second it will print 1. For every execution of printf statement, it is going to print 1. Correct? Clear? Now let us see. See here, it is printing for 1 for every execution. It is printing 1 for every execution. This is how I have removed my buffer. Clear with this example? Understood? Now I can change the size of my buffer also. I can change the size of my buffer also. Okay? If you observe here, if you want to remove the buffer, you can pass like this setbuf. In bracket you can write std out comma null. Null means what? I don't want to store my output in any buffer. I want to print my output directly to the terminal. Clear? Now suppose I want to change the size of my buffer. I want to change the size of my buffer. I want to create my own buffer. If I want to create my own buffer, I don't want to store my output to the std out. I don't want to store my output to std out. I want to store my output my own buffer. I want to create my own buffer. Suppose I am creating a buffer like this, char str. Of size I am taking 5. Means the size is 5. How many characters it can store? How many characters it can store? It can store a 5 character. Correct? Now what I am doing? I am changing my buffer. So I am going to write set buffer. Okay. Inside that I am going to write std out. Which buffer you need to change. After that, instead of there, I will write name. I will give my buff. My buff. Okay. I am changing it to my buff. And I am changing. I need to pass the size of my buffer also. I need to pass the size of my buffer also. Okay. So these are the things I am going to pass. Now tell me how output will be changed. Now your output is not going to std out. Your output is going to your my buff. Your output is going to my buff array. Now tell me what do you think how your output is going to print? How your output is going to print? For which condition your output is going to print? First of all tell me. First of all tell me for which condition your output is going to print? It is going to print when your buffer is full. Correct? It is going to print when your buffer is full. Now your which is your buffer? Now which is your buffer? Yesterday is your buffer or my buffer is your buffer? Which one is your buffer now? Which one is your buffer? Now your buffer is my buff. Now your buffer is a my buff. Okay, so whatever the output is that, it is going to the my buff. It is going to the my buff. Correct? So what is the size of my buff? How many characters it can contain? Only 5 character. Only 5 character. Means what will happen? 5 times 1 will be stored there. When this buffer become full, that 5 character will be thrown to the screen. Again it will start refilling. Means block by block it is going to print. That is called as block buffer. This is called as block buffer. If I'm going to execute it, okay, set buffer. See your output now. See, at a one time it is printing 5 ones. For every 5 seconds, for after every 5 character, it is going to print block by block. It is going to print. Understood? Everybody clear with this? For every 5 character, it is going to print. Are you clear with this? How can we change the buffer size? By changing the buffer. Instead of sending to the system buffer, I am sending my buffer, sending my output to my own buffer. See the code if you want. Note the code. This thing I am going to for removing the buffer. For this is for removing buffer means what? For unbuffered. Means I can see it as a unbuffered. It is called as unbuffered. It is called as a block buffer. Block buffer. Setbuf is nothing but what? Can you tell me for what is it again? Okay, I am going to revise. Tell me for what we are going to use setbuf. For what we are going to use setbuf. What am I, Saurabh? Okay, explain. Setbuf. Okay. Okay. So suppose I want to remove my buffer. I want to remove my buffer. So I will write a function like this setbuf. In that I am going to pass stdout common null. So stdout, the first argument is nothing but which buffer you want to remove. First argument is nothing but it is saying that which buffer you want to remove. Correct. So I am saying that I want to remove stdout I want to remove stdout Okay. Now which buff you want to add there? I don't want to add any buff, so I am passing null there. So I want to print my output directly terminal. Here generally I am passing the array. Like here I am passing my buff. Here so I can pass array also. But I don't want to store anything in my buffer. I want to directly throw onto the screen. So because of that I am passing null here. This was your setbuf function for unbuffered. Using this I am going to do block buffer. I have created my own buffer. Whatever the output is that I am sending my output to the my buff. And the size of that my buff is nothing but I am sending that 5. When this buffer become full, it is going to print on the screen. Understood? Clear with this? And you can use setline buffer also. You can use setline buffer so it will print output when your output contains /n. Okay, actually this setline buffer is similar to your what? Your normal buffer also. Your normal buffer also what it will do? It is going to print output on the terminal when it contains /n. Same thing it is done by your setline buffer also. When your output contains /n, at that time it is going to print. It is not that much important. Okay, let us see the example. You know all this thing. Now tell me the answer for this one. Example number 25. Tell me the output. If I am going to enter A, B, C, D up to Z. If suppose when user is going to read this first time, at that time I am going to print A, B, C, D up to Z. A, B, C, D, E, F, G, H up to Z I am going to print. Now tell me what your output is going to print and what for what reason reason it is going to print on the terminal. Once again I am telling the question. Suppose first of all what will happen? CH will contain Y. CH will contain Y character. Now after that it is going to print and it is going to store enter the string. It is going to store enter the string. Output buffer contain enter the string. Now your output buffer contain enter the string. Now next thing what I am doing? Now next thing I am doing checking that CH is not equals to character none. Character n. So your character y is not equals to character none n. So condition become true. So it will come inside. So when it will come inside at that time, enter the string will print on the screen because of reading. Because of reading, enters the string will come on the screen because of we are reading here. From the output buffer, your enter the string come on the screen. Now what I am doing? I am reading a input from the user. Suppose here I am entering A, B, C, D up to Z. For this scanf function, suppose I am going to enter A, B, C, D up to Z. For the first time only I am entering A, B, C, D up to Z. So tell me what it is going to print and what is the reason behind your output is going. What is the reason behind it? Tell me what it is going to print. Tell me what it is going to print. Tell me first of all. Tell me the output. First of all, everybody, tell me the output. What will be the output? What will the output for this question? If I am entering my input as a ABCD to the ABCD to up to Z, what will the output? My input is what? ABCD E F G up to Z. My input is like that. So what will be the output? Reply fast. Okay, slash n is also there. Banu Prakash, suppose slash n is also there. Then what will be the output? What is going to print on the terminal? What this program is going to print on the terminal? If I am giving input like A, B, C, D up to Z, after that I am pressing enter. Reply everybody. Kiran CM, please reply. Madhu reply. Madhu. Vishal Patil, Yoganathan, Vaibhav Anvekar, reply कर. Nikhil Tripathi, Lokesh Zamre, please reply. Don't attend the lecture. Please reply. Babu is saying up to Y it is going to print. Okay, Banu Prakash A to Z. Person C will store only one character. Person C A to N. Again. Others please reply. Lokesh, Vaibhav Anvekar, Kiran, Raja, Sonali, Vaishnavi Gurav, reply. Now who has given a to n? Answer is a to n. Okay, answer is a to n. So Babu, you are saying up to n it will be print, not y. Means what? Okay, so tell me the reason what up to n. Why it is, how it is going to print up to n? Koni Reddy also reply why up to n. Again who told tell up to n? And again who told up to n? Sukumar, please reply why up to n. You all three reply why up to n. Koni Reddy. After n while condition will fail. Okay then. Up to n while condition will fail. Then scanf is stop reading and printf f1. So what is the reason behind printing n? Because of termination or what? So see what will happen here. Suppose I am going to execute this program. I'm not I will first explain. So this is what your program is. This is what your program is. This is what your program is. Okay, what will happen? Initially, you are entering y. Sorry, initially we are not entering y. Y is going to store in a ch. Now ch contain y. After that, what will happen? We are checking that ch is not equals to n or not. So initially y is there. So y is not equals to n. So condition become true. So it will come here. It will come here. Now what will happen? I am going to enter ABCD up to n. I am going to enter ABCD up to n. So your standard input buffer contains what? STD. In contains what? Up to n. Sorry, up to z. A, B, C, D, E, F. Up to z it is going to enter. Suppose the slash n is also will also there. Slash n also there. After that I am going to press slash n. So slash n also there. So you from this, from the keyboard I have entered there this thing. From the keyboard I have entered this thing. So it is going to store in the standard input buffer. Now what will happen? You will call the scanf function. You will call the scanf function. Correct? You are going to call the scanf function. You are going to call the scanf function. Then what will happen? As you are going to call the scanf function, this, as you are going to call the scanf function, you are going to read the first character. You are going to read the first character. Okay, so when you read the A, at the time A will be removed from the buffer, and that A will be stored in what? That A is going to store in the A, in the ch. That A is going to store in the ch. Now what we are doing? From the ch we are going to print. So it is going to read by your printf function. It is going to read by your printf. From ch it is going to read by your printf. Your printf will send. Your printf is going to send this to where? It is going to send this output to the buffer, yesterday out buffer. It is going to send your output the yesterday out buffer. Suppose this is what your yesterday out buffer. This is what your std out buffer, std out. Okay, from that buffer it is going to print the output on the terminal. From that buffer it is going to print the output on the terminal. All of you clear with this example? That's why I'm taking so much time for this example. Okay, so initially a is read there. After that we are calling the function a, we are calling the printing function a, printf function, we are calling the printf function. So because of that, what will happen, this a is going to read by printf function and a will come here, a will come here. Now will it thrown to the terminal? Now it will thrown to the terminal? No, it will not going to the terminal. It will go only when one of the condition will satisfy. So it will keep there. So what will happen next time? Next time we will again come here and we will check ch is not equals to n or not. So again ch value is a at that time, ch value is a. It is a at that time. So condition become true. So I will come to read. But do I need to read from the keyboard? Do I need to read from the keyboard? Do I need to read from the keyboard? Only two students are replying. Do I need to read from the keyboard at this point? Do I need to read from the keyboard? No, I don't need to read from the keyboard because already there is an input in my buffer. Already there is an input in my buffer. So from that buffer, I am going to read the character. So I am going to read B. That B will be read by your scanf function and it is going to store in a ch. So it is going to store in a ch. Now ch contain B. Now I am going to printf c. Printf I am going to printing ch. So this printf function will read this B and it is going to send B. It is going to send B. Same process is going to happen. Same process is going to happen up to m. C, D, up to m it is going to happen. Up to m it is going to happen. Up to when? Up to m it is going to happen. Correct? Up to m it is going to happen. Next time when I am going to check m is not equals to n or not. Next time I am going to check is m is not equals to n or not. So what will happen? Condition become false. Now at that time what will happen? Condition become false. At that time what will happen? Condition become false. As condition become false, as condition become false, so sorry, condition become true because ch contains m, ch contains m, so m not equals to n, condition become true, so it will come inside, it will come inside. Up to m everything is removed, n is there now. So this scanf will read n, this scanf is going to read n, this scanf is going to read n, and now ch contain n, now ch contain n. Now what are you doing? Printf is printing this ch. So ch contain n. So this n also coming to here. This n also will come here. This n also will come here. Correct? After that, what will happen? Again, I am going to check for the condition. Again, I am going to check for the condition. Yes, n is not equals to n. This condition become false. So at that time, you will directly come outside. When you come outside, your program will be terminated as your controller will get the return 0. So whatever there in your buffer, it is going to print on the terminal. So A, B, C, D up to n, it is going to print up to n. Why will it come inside means what? Actually, %c will read only one character. At that time also, in standard input buffer, I already told Babu, %c is going to read only one character. No ch is a m. When it is entering, at that time ch is a m. Observe here. Okay, when ch is a m, suppose my ch value is m. Suppose my ch value is m. Consider now buffer container. Now suppose my ch value is m. When the from the buffer when ch read m, ch value become n. Okay, so you are going to print ch value. We are going to print the ch value, so it is going to store a m in the output buffer. Now what I am doing? I am going for condition checking. Now again I am going for condition checking. Now what is the value of ch, Anirudh? Anirudh, what is the value of ch? Ch value is m. Ch value is now m. Is m is not equals to n? Is m is not equals to n? Yes, condition become true. So I am going to enter inside this. I am going to enter this inside this. So I am going to read from the input buffer. Now what your input buffer contain? your input buffer contain n. So your scanf function will read this n. Your scanf function will read this n and it will store in ch. It is going to store in ch. Now what we are doing? We are going to print this ch. We are going to print this ch. So as it is going to this buffer. So after this m, n will be contained. Now your ch contain n. Now again I will go for condition checking. Now I will go for condition checking. N is not equals to n. Condition is true or false. Condition is false. So what will happen? Your loop will stop. Your terminated. So your control will directly jump from this point to this point. Your control will jump directly from this point to this point. Your control will get the return. As it is your control will get the return. Your program will be terminated. So whatever there in your output buffer, it is going to print on the screen. So ABCD up to n, it is going to print. ABCD up to n. And the reason behind this for printing ABCD up to n is nothing but it is a normal program termination. Understood everybody this example? Everybody clear with this example? Still anyone have doubt? Why it is printed output? Because the output is printed on the screen because our program is terminated. Then and only then you are actually to throw the output on the screen. Please reply. Everybody understood this example? Everybody understood this example? If I'm going to execute this, what will happen? So I'm trying to execute here. This is what our program is. Okay, I'm going to execute this. I'm going to enter A B C D E F G H I J K L M N. Now I'm pressing enter. Slash n also will be there. So it is printing up to what? A B C D up to n. Clear with this? Everybody clear? Now let us see another example. Is there any example is present? Okay. Now let us see one one more important thing, that is nothing but your first function. Next important thing is that your first function. Your first function. Fpurge function. Actually, it is nothing but this function is for your standard input buffer. It is similar to your flush function. All of you know about flush function. What is the use of flush function? What your flush function will do? What your flush function will do? Flush. What it will do? Your flush function, what it will do? It will forcefully throw the output to the terminal. Similarly, your first function is for this is function is for input buffer, but it will not throw input anywhere. It will directly erase the input. It will directly delete the input. Whatever there in an input buffer, it will delete that. Whatever there is in an input buffer, it will delete that. Your fpurge function will not flush anywhere. It will directly delete. It is not like a flush function. Flush means what? We are flushing the output to the screen. We are not removing. Here what we are doing? We are not flushing. Here we are directly deleting, or I can say erasing. Purge means what? What is the meaning of purge? What is the meaning of purge? Purge. What is the meaning of purge? What is the meaning of purge? Purge. What is meaning it? What is the meaning of this purge? What it means? Purge means delete. Purge means delete. So I am saying that whatever there in an input buffer, delete it forcefully. So let us see example. So let us try one example. So here is one example I am going to take. Here is one example I am going to take. So what will happen here? Suppose I am giving same input. Suppose I am going to give same input A, B, C, D up to Z. Okay, this is what example is. Same example I am taking. A, B, C, D up to Z. At the end I am writing slash n. Okay, so after this line I am writing fpurge. Okay, I am going to write fpurge. Fpurge. Okay, in bracket I need to pass the input buffer standard in std in. Okay, so what will happen when I am going to enter at this step? When I am going to enter ABCDs up to slash n, correct? So initially ch contain y. So when I am going to enter in a input buffer ABCD up to slash n, ABCD z, ABCD up to z. Okay, after that I am going to press enter. So slash n also will be there. So after that what I am doing? This scanf function will read. This scanf function will read a character from this input buffer. So A will be removed from this. This A will be removed from this, and A is going to store here. Correct? Like last example. But after that, what I am doing? I am calling a first function. I am calling a first function. So it means that delete whatever there in the buffer. Remove whatever there is a in an input buffer. Delete it. So what it will do? It will delete everything in this buffer. So because of this, what will happen? Whatever there is in buffer, it will delete. So it will be removed. Now your buffer become empty. Because of this function, whatever there in the buffer, it will be deleted. It will be erased. Nothing is there. Now buffer become empty. Now what I am doing? I am going to call a printf function. I am going to call a printf function. So this printf function will read this A. This printf function will read this A. So what will happen? A will be here. A will come here. Now A will come here. Now A will come here. Correct? Now A will come here. A will become in a std buffer. It will not going to screen. Now what about now? I will go for again condition checking. Is A is not equals to n? Is A is not equals to n? Condition true or false? Condition is true. As condition is true, it will come inside. As condition is true, it will come inside. So tell me what will happen here? It will wait for a keyboard, or it will read input from the std. Is there anything in std buffer? Is there anything in the std buffer? No. So what it will do? It will wait for the keyboard. It will wait for the keyboard. It will again wait for the keyboard. So suppose I am entering again BCDEFGH. If I am entering again BCD up to Z, again what will happen? This scanf will read only B. This scanf will read only B. This scanf will read only B. Because of this scanf, B will be removed. Because of this scanf, B will be removed. Now after that, I am calling a first function. I am calling a first function. So it means that remove all the thing, whatever the standard input buffer. So it is going to remove all this thing. All things, whatever the things are there in input buffer, it will be removed. Again, what will happen? Again, I am going to call a printf function. So because of that, what will happen? B will go to the. But just one thing, tell me. When I am going to wait for the keyboard, at that time this A will also going to print na. At that time A is also going to print na. When I am going to wait for the keyboard, at that time from the standard output buffer, A is also going to print on the terminal na, correct? So A is going to print, A is going to print here. So it is removed from the output buffer. And what will happen? This B is going to store here. B is going to store here. Next time what will happen? Again it will come here. Again it will come here. We are waiting for the keyboard. Read. We are waiting for the keyboard. Anirudh. We are waiting for the keyboard. That's why here A is printed on the screen. Now here what will happen? Suppose I am coming for second time condition checking. B is there. CH will contains B. So B is not equals to N. So condition become true. I will come here. I will come here. B is not equals to N. So condition become true. I will come here. So your scanf function will read. But there is no input buffer. So what will happen? We will wait for the keyboard. As we are going to wait for the keyboard, this B will be removed from the output buffer and B will come here. B will print on the screen. And after that, we are going to read the input. Suppose I am going to enter C, D, E, F, G, H up to Z. So what will happen? This scanf function will read C. So C will be removed. And C is going to store here. Correct? But after that, again there is a first function. So because of that, everything will be deleted from the input buffer. Now I'm going to print CH. So CH contains C. So C is going to print. So CH first it will go to the buffer. Means same thing is going to happen here. Same thing is going to happen here. Correct? Only difference is that your A, B, C, D, whatever things are, they are going to print on the terminal one by one. Here, last time in the last example, all A, B, C, D are printed at the one time. Here A, B, C, D will print one by one. Correct? Every time first character will be read and remaining character will be deleted because of your F first function. So I will execute the code. Let's see. What is the example number is? Example number is not there. Okay. I'm going to add here F first function. fpurge. You need to write like this. std in. If you want to use this function, you need to write like this. See here, 2 times this space, this underscore. After that F first, and in bracket you need to write std in. I'm going to execute now. Initially, I'm going to enter A, B, C, D, E, F, G, H. Suppose I'm going to enter like this. Okay, tell me what will happen now. I'm going to enter like this. Tell me what will happen. I explain the code. Tell me what will happen now. A will be read and it will be printed. So suppose I entered. Suppose I press enter here. I press enter here. A will be printed. Again it is waiting for the. Again it is waiting. Your your function is waiting for the keyboard to enter something into the input buffer. Suppose I am entering like this. Now tell me what will happen. W is going to read. W is going to read. Now W is printed. Now suppose I enter this many characters. What will happen? Will it print N? Will it print N? Will it print N? Yes, n is going to store there. N is going to store there. Correct. N is going to store there. This n is going to print because of normal program termination. See, here n is printing. This n is printing because of normal program termination. You are going to read n here. N will be read by your buffer. After that, you are going to call the function. You are calling the printf function. Because of that, what will happen? N is going to store. Because of that, n is going to store in output buffer. Now what you are doing? You are going to check the condition. In condition you are checking. N is not equals to n. Condition become false. So your program will be terminated. And because of that, normal program termination, n will be printed on the screen. For remaining A and W, it is printed because of, you are going to read for second reason. Sorry, third reason. Because of third reason, A and W is printed, but n is printed because of what? First reason, normal program termination. Understood this thing? Little bit clear? This is what we can do with the function. We can do the same thing using manually without using any function. I can do like this. Understood what it is saying? Can you tell me what it is saying? Instead of using this line, this function, standard function, I can do manually like this. What will happen here? Please explain what will happen here for this line. See here, I am writing semicolon here. After this bracket, I am going to call semicolon. So what will happen? Whatever there in a buffer, whatever there in a standard input buffer, this getChar function is going to read until what? Until you are getting a /n character. Means because of this, what will happen? Everything in the buffer will be removed. Because of this getChar function, it is going to read until you are getting the /n. Means I can write like this also, this line also, this function. I want to write manually, so I can write like this also. Understood? This thing understood? What it is going to happen here? Because of this getChar, what it is going to do? It is going to read from the standard input buffer. It will keep reading. It will, this loop is going to execute until what? Until it get /n. So we are entering /n at the end. Because of that, what will happen? Your buffer become empty. And it is going to print A on first time. It is going to print A on the terminal. After that, again we are going to read. Again we will to wait for the keyboard. Because of the what happened last time, because of this execution, our buffer become empty. So we need to again wait for the keyboard. Clear with this thing? Everybody clear with this? Everybody clear with this? Please reply. Any doubt you have, please reply, guys. Because your chapter buffer and your standard input output both are completed here. Your both the chapter completed. Standard input output and buffer completed. Any doubt in these two chapter? What? getChar will also purge std means what? What you are doing, Anirudh? Observe here. Is that code? What we are doing? Suppose I am entering ABCD. Suppose I am in input buffer. Okay, observe here. Initially, I am going user and it is going to print on the terminal. First time ch value is y. First time ch value is y here. So y is not equals to n. So condition become true. I will come inside. So because this scanf function is going to read the input. Suppose I am entering ABCD up to Z, and after that I am going to press the enter. Means at the end, which character will be there? At the last /n will be there. Enter means what? /n will be there. Correct? So this %c will only read only the first character. It is going to read only A. This %c is going to read only A. So this ch contains what? A only. Remaining BCD up to Z will be remains in the buffer up to /n. This BCD up to Z and last character slash, and up to that it is remaining in the standard input buffer only. So after that, what I am doing, I am executing one loop. In that loop, in a condition, what I am doing, I am reading a input from the input buffer by using getChar function. Okay, I am whatever your function is going to read, I am comparing with the slash n. If it is equals to slash n, I will stop it. But if it is not equals to slash n, I will come inside. This is nothing but empty statement. After that, again it is going to read. First time B it is going to read. B is not equal to slash n. So condition become true. Again it will go for checking. Again it is going for reading. Again the next time it is going to read C. Again condition become false. Next time D. It will keep reading. Means one by one it is going to read one character from the buffer. Standard input buffer. It will keep reading up to what? When slash n will come there. When your getChar function reads slash n, that is your last character. At that time condition become false. At that time condition become false. But at the same time your buffer become empty. Means this statement is doing the same thing what your first function is doing. This function is doing the same thing what your first function is doing, deleting the all the input from the buffer, deleting all the data from the standard input buffer. Understood now? Now clear? Nagendra, clear? Clear with this? Any doubt in this chapter? We have completed basic refresher, function, this strings, standard input output buffer, then buffer, standard input output, and then buffer. We have completed 5 chapter. Now we are going to start the 6th chapter. In first 5 chapter, any doubt? Any doubt, guys, till now? Any difficulty you face up to this syllabus? Please reply so that we can move to the next chapter. Please reply, guys. Please reply. Okay. Your next chapter is the storage classes. Your next chapter is the storage classes. Storage classes. Okay. Just wait for 2 minutes. I will come. Just 2 minutes. I will come. Okay guys, let us start next chapter, that is storage classes. Okay, actually this is not a separate topic. This storage class is not a separate topic. It is not a separate concept. Actually, the concept, whatever we are going to see. Okay, Akula, I will take this later. I will going to take, but I will take this later. Doubt session chapter, doubt session class. Okay, okay. Currently, I don't have time, but I will take it later, one day. Okay, actually, your storage class is not a separate topic. Whatever the concept we are going to see in the storage classes, those concepts we are going to use in every program, whatever we are going to write, whatever we have written already. The concept of this we are going to use everywhere. Any program you are going to write, that concept you are going to use everywhere. It is not a separate topic. The storage class means what? Storage class means when you declare the variable, when you are going to declare the variable, what are the properties of that variable? Where the memory allocated for that variable? Where we can access that variable? What is the lifetime of that variable? What is the scope of that variable? All these things we are going to study in the chapter. When you are going to declare whatever the properties associated with that variable, lifetime, scope, whatever the things are there, memory allotment, all these things we are going to discuss in this chapter. Till now we have covered only the local variable. We have covered local variable. What is local variable? Till now we have covered local variable. So what is local variable? What is local variable? How will you define local variable? Declare only in main function, Vishal. If you are declaring any variable inside the function, if you are declaring any variable inside any function, if you are declaring the variable in, if you are declaring the variable inside the any function, maybe it is a main function, or maybe it is a user defined function. If you are declaring inside the function, it is nothing but it is a local variable. It is a local variable. Then before we have seen again we have seen another variable, that is static variable. What is the meaning of static variable? What it means static variable? Where memory will be allocated for static variable? Yes, memory will be allocated in the data segment. So apart from this, we have three more type of storage classes. Apart from this, we have three more type of storage classes. First is a auto local. First one is a auto or local. Like we call it as a sometime auto, or I can call it as a local. Local. Okay. So before going into detail, first of all, tell me when I am going to execute my program in the RAM, I will get the memory. So it is going to divide it into four parts. So what are those four parts? When I am going to execute the program in the RAM, at that time your memory will be divided into four parts, correct? So what are those four parts? They are nothing but code segment, data segment, correct? Heap, and last is a stack. These are the four segment: code segment, data segment, heap, and a stack. So from this stack, the data segment and heap are used to create the variable. In this we can create a variable from this data segment, from this 4 segment, in the stack, in the heap, and in the data segment. In this 3 segment we can create the variable. In this 3 segment we can create the variable. But this code segment is not used for creating the variable. This code segment only contains the constant values. Your program machine, your program instruction in a binary language and a constant values. This code segment contains only the program instruction and a constant values. Whatever the variable are there, they are going to create in a stack memory, heap memory, and data segment only. So when you declare a local variable, that is going to create in the stack only. When you are going to declare a local variable, it is going to create in the stack only. Where whatever the local variable you are going to create, that is going to create in the stack memory only. So it is called as the auto variable. It is called as the auto variable or a local variable. We never use a auto keyword before. When you are going to use a declare a before inside the function, we never use a auto keyword. Generally, when you are going to declare like this int x, at that time by default it is nothing but it is a signed int x. How, why we are not using signed? We are not going to use signed there. By default it is signed. Similarly, if you are going to declare a variable inside the function, if you are going to declare a variable inside the function, if you didn't mention anything before the variable, if you just declare like that int x, it means that by default it is a local variable or auto variable. No need to mention that like a sign. By default the variable is auto signed variable. If nothing is mentioned, by default variable is nothing but auto signed int x. But we just write int x only, because by default variable created in a function are auto and signed, and the memory for auto variable will be created in the stack segment only. Whenever the function is called, generally stack is created. Inside the stack only we are going to create the variable. That variable are called as auto or local. Next type is the register. Okay, next storage class is a register. Register variable. Actually I will explain this register variable later in detail. It is almost similar like to your auto, only one change is there. This register variable is similar to your exactly auto, only one change is there. I will explain it later. Another type is, next type is a static local, which we already saw. Static local, we already saw static local while seeing the recursive function. Next is a static global. Next is a static global variable. Again there is a one another external global. And last is a function argument. Okay, it is not important because it is nothing but it is a auto local variable directly. It is nothing but auto local variable. It is going to create in the stack only. Function argument, we already know what is function argument. What is function argument? In the function chapter we have seen what is function argument. We don't need to learn this. Function argument are nothing but what is function argument? Input to the function, where the memory for this function argument is there, where it is going to create, in the which part it is going to create this function argument. They are going to create only in stack, so it is similar to your auto local. So these all these storage classes we are going to discuss. We will see all this one by one. Now we are discussing auto and local. Okay, so far we covered about auto and local. So how will you define local variable? If you declare any variable inside the function, it is nothing but auto local variable or auto or local. If I'm writing a function like this, int main, suppose I'm doing like this int x, This is my main function. Okay, I am creating user defined function int foo. I'm declaring int I. These both x and I are nothing but they are local variable. They are both are defined inside this function. X is defined in the main function and I is defined in the foo function. Both are a local variable. This x is local to main function. This I is local to foo function. When this variable is going to create, this variable is going to create when you are going to call the function. At that time it is going to create. So now let us discuss the important thing about the variable, that is nothing but lifetime and the scope of the variable. Lifetime and the scope of the variable. Lifetime and scope of the variable. What do you understand by lifetime? What do you understand by lifetime? Lifetime is nothing but it means that when your variable is going to create, lifetime is nothing but it is nothing but when your variable is going to create and when it is going to delete. It is nothing but lifetime of variable. When it is going to create and when it is going to delete, that is nothing but lifetime of the variable. Understood? When it is going to create and when it is going to delete, that is nothing but lifetime of a variable. And scope means what? Where we can use that variable, where we can access that variable by using that variable name, where we can use the value of that variable. That is nothing but scope of that variable. That is nothing but scope of variable. Where we can use it, that is nothing but scope of variable. Where we can access it, that is a scope of variable. And lifetime is nothing but when it is created and when it is deleted, that is your lifetime of the variable. Okay, so when you talk about your auto local variable, when you are going to talk about your auto local variable, what do you think what is the lifetime? What do you think what is lifetime? What is the lifetime of your auto local variable? When your local variable will be create, when it is going to create, when you are calling the function. Okay, but in a simple way, in a specific way, I can say that this variable is going to create when your this block start. This curly bracket, two curly bracket is nothing but this is a block for this variable. This curly braces is nothing but this is a block for this variable. This is a start of block and this is the end of block. So when this block start, at that time this variable is going to create. When this block start, at that time this variable is going to create. And this block end, at that time this block is going to delete. When this block is going to end, at that time this variable is going to delete. So for this variable, the lifetime, the lifespan is nothing but what? This block, start of this curly braces and end of this curly braces. Correct? For this I, the lifespan is nothing but this block, start of this block and end of this block. Suppose I am going to create a variable like this. Int y. Now tell me what is the lifespan for this y? Lifetime for this y? What is the lifetime? Correct, Uday? What is the lifetime for this y? When will this y variable will create? Please mute. When will this y will be create? For this y, the lifetime will be these two curly braces. This y is created inside these two curly braces. So lifetime will be these two curly braces, this block. This y will be created where this block start and it will be deleted when this block end. If you are trying to print the value of y here, if you are trying to print the value of y here, it is not going to print. It will give error to you. Outside this block, if you are trying to print the value of y, at that time it will give error because it is deleted at this point only. This y is deleted at this point only. The lifetime of this y is nothing but this block only. You have to be clear with this lifetime. Everybody clear with the lifetime? Lifetime is nothing but in the block where it is created, the start of block and the end of block. Clear with the lifetime? Now when you are talking about scope, when you are talking about scope means what? Where we can access the variable, where we can access the variable. So can you tell me, suppose this is x variable, consider this x variable. If I am trying to access this variable x inside this foo function, can I access it? Can I print the value of x here? No, I can print the value of x only inside this block only. Inside this block, anywhere I can print the value. Similarly, the value of y, I can print inside this two in the block this. This is what the start and end of the block for y. Inside this y, inside I can print the value of y only. Outside this, I cannot print. It will give error. So the scope is also what? Scope is nothing but the block. Scope is nothing but also what? Block. Means inside this block, you can access this variable anywhere. You can use the value of variable anywhere. That is nothing but lifetime and scope of the variable for local variable. Okay, let us see. Okay, if you observe here, see this table for local auto variable. For local auto variable, the scope is nothing but it is a block. Scope is nothing but it is a block. Lifetime is nothing but what? Between the block entry and block exit. Your lifetime is nothing but between the block entry and block exit. It will create when block start and it will end when, it will delete when you are going to exit the block. And your scope is only block. And memory for local variable is allocated into the stack segment. Memory for the local variable it is going to allocate in the stack segment. Clear with this? All of you clear with this? Clear with this thing? Local variable, auto variable. All of you clear with local variable? What happens, Saurabh? Please tell me what happened. What happens, Saurabh? Because what will happen there? This is a local variable. What I told, this is a local variable. The scope of the lifetime of y is nothing but the block only. So for this y, which one is a block? For this y is created in which inside two curly braces. This y is created inside these two curly braces. This y is created inside these two curly braces. This y is declared inside these two curly braces. So this y is created when this block start, and this y will be removed from your memory when this block will end. When you are going to execute the next step, at this point y will be present in your memory. At that time y will be present in your memory. Will that y will present in your memory? Saurabh, when you come to this step, we will this y will come to your memory. Will y is present in your memory? This y is going to create when this block start. This curly at this point it is going to. Okay, there is example also I will take. Okay, let us see some examples so that you can understand. If you first see the first example, what do you think? What will happen here? This is nothing but what? What type of variable it is? What type of variable it is? This what is the type of this variable? It is a auto local variable. Okay, signed int means what? Local variable. It is declared inside the function. It is a local variable, correct? So what is the lifetime and scope for this variable? This is nothing but this two block. This is created inside this two block. So lifetime and scope is nothing but this two block. Okay, correct. So I equals to 0. So what will I print? We can accessing inside the block only. Inside the scope only we are accessing. So will it print 0? It is going to print 0. Correct. Everybody knows it is going to print 0. Now let us take next example. Let us take next example. In this example, what I am doing? I am created one foo function. I am creating in foo function. I am going to call it. In the foo function, I am going to create a variable I equals to 0. I am trying to print the value of I. What will happen? Will it print? What will happen? Will it print? Yes, for this I variable, scope is nothing but these two curly braces. So inside these two curly braces, we are going to print it. But if I am trying to print I here, will it print? If I am trying to print I here, will it print? No, it is not going to print. It is not going to print. Okay, let us some more example. Okay, now this example. Now tell me what will happen here. Now tell me what will happen here. What will I will print and what will J will print? Or it will give error. This is what example is. Example number 6. Why error? I is out of scope. I is in a scope. I is in a scope. The scope of I is what? Scope of I is what? Will I will give you error or will J will give you error? Printing of I will give you error or printing of J will give you error? Printing of J. Why? Because this I, for I, scope is nothing but, lifetime is nothing but this entire block. This I is created inside these two curly braces. So inside these two curly braces, I can use it anywhere. This I can use it anywhere. I can use here also, I can use here also. But for J what? Scope is what? Only these two curly braces. For this J, scope is only these two area, these two curly braces. It will be create when it is start and it will be delete when it ends. So what will happen? J will create when this block start. But when you come out of this block, at that time J will be delete and you are trying to print J. Means J is not present there. J is not present there. So because of that, J will give you a error. J will give you a error that undeclared. Okay, we will try to execute this code. Where storage class is here? 9. Okay, this is what example is. Correct? This is what example is. If I am trying to execute this code, let us see what will happen. See, it is printing J is undeclared. j is undeclared because what will happen? Whatever the j is there, whatever j is there, it is going to delete. When this block ends, this j will be deleted from your memory. This j will be deleted from your memory. It will create only when this block starts. So inside this block, we can access it anywhere. This thing, we have used this many things. We have used like this, but we don't know this property. That's why we are going to learn more about your variable. What are the things? What are the properties of what will happen? This thing we don't know. That's why we are going to learn this chapter. Some more thing about your variable. What are the things? What are the things are associated with your variable? So this thing you don't know. Now you understand? If you are trying to create like this j will be deleted here. Everybody clear with this thing? Because lifetime is what? The block start and block end. We can access inside the block only. Now understood, Saurabh? Other clear? Similarly, tell me for this question. Example number 7. What it is going to print? For this j, for printing this j, it can print this 10 also and this 0 also. But it will take the closest scope. It will take the closest scope. It will take the closer one, which having the closest scope. So for this one is closer. So it will take a 0. So this will print 0. And it is going to print what? For this only one j is there, only 10, because this j will be deleted when you come outside this block. This j will be deleted when you come outside this block. So this j is going to print for this j. This 10 is going to print for j. So output will be 0 and 10. Understood this example? Everybody clear with this example? Now tell me what will happen. Can we do like this? Here I am declaring variable multiple times. Here I am declaring variable multiple times. Why? Why it is possible? Here I am declaring variable multiple times. No error I am getting. Here I am not getting any error because this j is different. This j is having different scope, and this j is having different scope. The scope of this j is different. The scope of this j is different. Because of that, it is possible. But here what I am doing is I am creating the variable I, both having the same scope, same lifetime. So your compiler will confuse for printing the I. Which I value should I give? Whether I give I this 10 or whether I give this 20. So your compiler will show a multiple definition error. Clear with this? So it is not possible here. Why it is not possible? Because the scope of both the I is same. So because of that, multiple definition is not possible. But here scope is different. Means I can declare the variable with a different scope in a single file. Clear with this thing? Clear? Clear with this? Now tell me, for example number 3, we have seen this example already. Now tell me what will happen here. Why it is not going to give? Tell me for example number 3. This example we already saw in before in a function chapter. If you remember, in a function chapter we already saw this example. There we have learned one concept that we cannot return the address of the local variable. Correct? So what is happening here? In a main function, I am creating one pointer I. In a main function, I am creating one pointer I. Okay. In that I am trying to store the whatever the output is from foo function is going to return. Suppose foo function is going to return as here we are calling the foo function. As here we are calling the foo function, so stack will be created. The foo stack will be created. In that foo stack, I is going to create. In that foo stack, I is going to create. Suppose this is a full stack I have created. In that full stack, I is going to create. Suppose I is contain 10. I contain then 10 there. So memory is allocated there for I. And the address you are suppose 100 address is there. At the 100th memory location, I is there. I value is stored there. Correct? What I am doing there? I am storing the address of a j, address of the I variable inside the j variable, inside the j pointer. Now what will j contain? Now what will j contain? What will j contain? J will contain 100. J will contain 100. And I am returning j. I am returning j, means I am returning the 100 to the function. I am returning 100 to the function. Okay, when I am going to return the 100 at that time, whatever the stack is there, this stack will be deleted. This stack is going to delete. Whatever the memory was there, we don't have access on that memory. And now I don't have access on this memory. When stack was there, I was the access on the memory 100. But now I don't have access on this memory as the stack is deleted. So this 100 is going to store in the I variable. And I am trying to dereference that I. I am trying to dereference the 100. I am trying to dereference the 100. Means I don't have access on that 100. And I am trying to dereference it. So what it is called? Yes, Anirudh, correct. It is called as a segmentation fault. If you don't have access on the memory and if you are trying to access that memory, it means that we are doing illegal access. At that time, you will get a segmentation fault. Either you can get a garbage value or sometimes you will get a correct value also. Means you will get undefined behavior. Because of that, I already told you cannot return. Don't return. You can return, but don't return the address of the local variable. Don't return the address of the local variable because it is going to delete. When you are going to return the memory, it will not be in our access. Memory will be there, but it will not be in our access. When stack was there, it was in our access. Now when you are going to return, at that time it will not be in our access. Understood this example? Clear with this thing? Next example, same thing here. Same thing. This character array will be created where? In a code segment or a stack. Where it is going to create this character array? Where it is created? In a code segment or a stack? Yes, it is an array. It is going to create in the stack. So this is going to create in the stack. So when you are going to return the address of the CA, when you are going to return the address, at that time this stack will be deleted. And we don't have access on this memory, whatever we have stored. We don't have access there. And we are trying to access this. We are trying to print this. Whatever the store in the memory, we are trying to print this. Again here, what will we get? We will get either segmentation fault, either garbage value, or sometimes we will get a correct answer. So I can say output is a undefined behavior. Clear? Next thing. What will happen here? What will the output? What will count print? What will count print? I am expecting answer from you. You have objective test 2 on this Sunday, na? This Sunday, Monday, maybe. I don't know. This week your objective test 2, na? So you should give all this answer. Such type of question will be there. Actually, this is nothing but these are function questions. These are functions questions only. You should reply this question. If you are not able to reply, means what? You forgot all this thing, whatever we have taken. Function chapter. You have to draw the stack for every time. For objective test, do all the example. Whatever I have solved in the class. Try to solve again all the example. See all the concept what I have taken. Read all the concept. See all the PPT examples. From that concept only it will objective test will be there. Correct. Output will be one only. Output will be one only. What will happen here? First time what will happen here? Count variable will be created. After that, you are going to store the output which is written from the function. Correct. So when you are going to call the book ticket function, when you are going to call this book ticket, at that time a stack will be created. At that time, stack will be created. Correct, Swastik. At that time, stack will be created. In the stack, I am doing ticket stored equals to 0. Means I am creating a ticket stored variable in the stack. This will be created in the stack because it is a local variable. It is created in the stack only, stack memory only. So I am making it as a 0. Now I am going to increase the value of ticket sold. So ticket sold become 1. And I am returning 1. So count will be return 1. Count will store 1. But what will happen when you are going to return? At that time the stack will be deleted. At that time stack will be deleted. So whatever the things you have created in the stack, that will all these things will be deleted. Again you are going to call the function second time. Again you are going to call the function second time. Second time what will happen? Again you will create a stack. In that stack again you will create this variable ticket sold equals to 0. Again you are going to increase the value. It become 1 and you are going to return 1. So this function is going to return 1. So count will contain 1. So it is going to print count is a 1. Correct. Count is going to print a 1. Clear with this? Are you clear with this all this example? Whatever the things I have taken about your local storage class, everything is clear. Local variable, where it is created, what is the lifetime, what is the scope, and example whatever I have taken. Already these 3 example you should know. The function chapter, these 3 example are nothing but these are 3 example are from function chapter. You should know these 3 things. 1, example number 3, 4, 5. If you don't know it, then you need to revise. Otherwise, you will not score in the test. These are the easiest example. These are not difficult. These are the easiest. Somewhat tricky paper will be there. See all the thing, how to access the array, array representation, pointers, everything will be there. Any doubt in today's session, guys? From the first chapter till second, up to the string. String will not be there up to the string. Whatever their points we have covered will be there in objective test 2 from the first chapter. First chapter is nothing but basic concept. This concept which we are going to use in every chapter. So always first chapter will be there everywhere. You're already clear with this? All the things we have taken in today's session.